Hello, if you are new to this channel, my name is Brittany and I'm a Solutions Architect at AWS. I spend the majority of my time working with customers to help them understand both the stack of services available on the AWS cloud and how to combine those services to form different architectures for different workloads. During these videos, I take the topics that my customers frequently find ambiguous or overly complicated and break them down into the simplest terms. Today, we're going to be talking about the AWS Global Infrastructure. Now, unless you're a network engineer or an infrastructure admin, you probably don't need to understand the AWS Global Infrastructure in 300-level detail. But if you're planning to leverage the cloud in any capacity, you should make an effort to understand core services and concepts like what is a region, what's an availability zone, and what's an edge location. The global infrastructure is the foundation for all AWS services. Whether you're planning to leverage core capabilities like compute, storage, and database, or higher-level services like serverless functions and machine learning. So, without further ado, let's get into it. When I'm talking about the AWS Global Infrastructure, I like to start small and work my way up. So ultimately, when you upload a file to AWS or deploy a piece of software, at the lowest level, it's going to be stored on a server in an AWS-owned and operated data center. However, when I upload a file to the cloud, I'm ultimately looking for a greater level of availability and reliability than I could achieve storing it in my own data center. I don't want to lose the file if something were to happen to the data center, and I want to be able to access that file from a wider range of locations with the same high performance. Let's say a weather or maintenance event does occur, and the data center housing my file goes offline. AWS has planned for this with redundancy. AWS clusters data centers together around the world, so AWS will have a second data center connected to the first through redundant, high-speed, and low-latency network links. That cluster of data centers is called an availability zone. Each AZ contains its own redundant power, networking, and connectivity, so if something happens to my original data center, it won't take down the remaining data centers in the AZ. Unfortunately, natural disasters like a hurricane might span to affect an entire cluster of data centers. But AWS plans for that level of redundancy by clustering availability zones together and connecting them with those same redundant, high-speed, and low-latency links. A cluster of availability zones is called a region. All availability zones within a region are separated by a meaningful distance, although all are within 100 kilometers of each other. Because of this, you're able to achieve single-digit millisecond latency between the availability zones within a single region. Now, when you actually go into the AWS console, you choose the location of your resources by picking the region, generally named for the physical location where the cluster resides. For instance, the North Virginia region resides in North Virginia in the United States. We currently maintain 31 regions around the world, with announced plans for 5 more AWS regions in Canada, Israel, Malaysia, New Zealand, and Thailand. Customers typically choose a region based on compliance, performance, price, and service availability. Do you have specific data residency requirements? You'll need to choose a region within your specific country. If you don't have regulatory requirements dictating your region, you can make the decision based on latency and how close your IT resources will be to your users. For example, if all of your users live in the Pacific Northwest United States, the latency is going to be lowest in the Oregon region, so it makes the most sense to deploy your resources there as opposed to North Virginia. Pricing also varies region to region due to different tax structures, so some regions may be more expensive for you to operate in than others. And finally, you'll want to look at service availability. Typically, new services get rolled out to a subset of regions first, before becoming more widely available. The next choice you have, once you choose a region, is how many availability zones within that region that you want to operate within. As a reminder, each availability zone within a region is a fully isolated partition of the AWS Global Infrastructure. This means that it is physically separated from any other availability zone by a meaningful distance within 60 miles to allow you to achieve synchronous replication between availability zones. Availability zones give customers the ability to operate production applications and databases that are more highly available, fault-tolerant, and scalable than would be possible from a single data center or even a single cluster of data centers. Now, one of the first questions I often get is, should we build within a single region using multiple availability zones, or should we architect across multiple regions? It comes down to the desired availability and resiliency of your workloads. Most AWS customers can achieve their resiliency objectives for a workload within a single region by using multiple availability zones. However, a subset of customers do pursue multi-region architectures for 3 reasons. The first, they have high availability and continuity requirements for their highest tier workloads that they believe cannot be met within a single region. Second, they need to satisfy data sovereignty requirements such as adherence to local laws, regulations, and compliance, which require workloads to operate within a certain jurisdiction. And third, they need to improve customer experience and performance for the workload by running that workload in locations closest to each set of end users. So, if your users are in California and Ireland, yes, we might want to explore 2 regions if performance for one of those user bases is poor. However, the trade-offs to using multiple regions are cost and complexity. Most AWS services are regional, meaning they operate within the bounds of a single region. So if you're replicating between California and Ireland, you're most likely standing up a full second instance of your environment and potentially transferring data across extremely long distances. Those costs are going to add up quickly, and the complexity of a cross-region network just might not be worth it. A performance improvement option that I'd recommend before looking at multiple regions is leveraging the AWS Edge Network. Amazon CloudFront is a web service that speeds up distribution of both your static and dynamic web content, such as HTML, CSS, and image files to your users. CloudFront delivers your content through a worldwide network of data centers called edge locations. So, when a user requests content that you're serving through CloudFront, the request is routed to the edge location that provides the lowest latency, ensuring that the content is delivered with the best possible performance. That routing of user requests all occurs over the AWS backbone. Using the AWS network dramatically reduces the number of networks that your user requests have to pass through, which improves performance. Users get lower latency and higher data transfer rates. You also get increased reliability and availability because copies of your files are now cached in multiple edge locations around the world. Amazon manages and operates 100% of its global network. Every data center, availability zone, and region is interconnected via a purpose-built, highly available, and low-latency private global network infrastructure. What does this mean for you? By moving traffic off of the public internet and behind the defenses of a secure cloud provider, you limit your exposure to attacks by encrypting data, removing network hops, and controlling application access. So, that's it. The AWS Global Infrastructure in under 10 minutes. It's confusing when you go to design an application and are met with all of these options for regions and availability zones. But when you start at the individual server and work your way out, things start to make sense. All of these constructs exist to help you design applications that meet your unique business continuity goals. Like always, thank you so much for watching, and let me know what other cloud computing topics you need simplified.